To wrap up what we learned that work can be due to conservative force or to non-conservative force, and in all cases the total work is equal to the total change in the kinetic energy. That is the work energy theorem. If there is a change in potential energy, then we have to include that in the equation when we calculate the total work. So the total work against non-conservative force is equal to the change in the mechanical energy, the final mechanical energy minus the initial mechanical energy, and the final mechanical energy has kinetic plus potential terms. The initial mechanical energy has kinetic plus potential energy terms. E final minus E initial, we may write it in a fancy form as delta E. Delta E means the change in the energy. Okay? The change in the total mechanical energy is related to the work against non-conservative force by this formula. If there is no friction, if there is no non-conservative force, so this is 0, in that case delta E equals 0. When delta E equals 0, the energy is conserved, it doesn't change, it is constant. In that case, what we encounter is just a transformation of potential energy into kinetic energy or kinetic energy into potential energy, but the total energy remains the same, constant. In general, there are 3 methods of transferring energy into a system: kinetic, potential, as we learned, and we add a third form, which is internal energy, the energy of atoms and molecules. Like if you heat an object, you are increasing the internal energy. You are exciting the atoms and molecules. The heat energy is converted into higher kinetic energy for the atoms and the molecules. On the other hand, there are 5 methods of transferring energy out of a system: by doing work, by heating, by mechanical waves, by electrical transmission, and by electromagnetic radiation. When we do work, energy is transformed to another system simply by displacement. You are applying a force to displace an object. So in this case, energy is used to do work. Heat, in this case, energy is used to excite the atoms and molecules more, and if you check them under the microscope, you will have more collisions between atoms and molecules. In mechanical waves, like sound waves, energy in this case creates a disturbance in the medium, which is the atmosphere, the air, that allows the sound waves to propagate. In a similar form, electrical transmission and electromagnetic radiations, energy, in this case for radiation, energy is transformed from the form of electromagnetic waves like light, like microwaves, like radio waves. These are all forms of energy. For electrical transmission, energy transfers through electric currents in the circuit, which is used to have the appliances function. So in all these systems, we are dealing with energy, and energy is always, the total energy is always conserved. It is only changed from one form to another form. The principle of conservation of energy is an important principle. Once you understand it well, you will have a better understanding to the physics world around you. In this picture, we see how a plant uses chemical energy to convert it into light. So the red areas here are the chlorophyll, which is fluorescence when irradiated with blue light. It is a process for energy transformation.